users in chat. It's not even not even me. What's up with these? I thought the broadcaster is always appearing there. Let's see. Is that real life? Is that really live? Empty stream titles are not allowed. It's not empty. No, it seems I'm live. Okay. Am I though? I guess we'll figure it out soon. So let's see. I can go here. My channel. Yeah, it says I'm live. Awesome. Still trying to find a way to. What was that? I think there was I found yesterday an easy way to share Stream Manager, and then I go to settings. No, go to edit, exactly. Share link to channel. And now I can just share it on Twitter like these. Yeah, cool. That's perfect. Awesome. So we're gonna do roughly 40 minutes or something like that. That's the time that I have today for these. Not much, but we'll get there. We'll get there with the rule stuff, right? So that's what we're going to implement. Doesn't need to be that big. Now, is this well set up? I forgot. I guess so. That's the correct Python interpreter. That's in the notebook as well. And if I just rerun these, doesn't work. Okay, because I need to change. But now that doesn't appear here. Select interpreter, Python. How was that? Python. So, new terminal, new terminal. Oh God, I'm so. Control Shift P, Python select interpreter. There you go. But then why does it not appear here? Dude, that was working. That was actually working. Oh, there. Oh, oh, it was there for a second, but it's gone now. Why? It was there for a second, but it's gone. I don't get it, man. I really don't get it. Oh, because it's not started. So yeah, okay, I gotta activate it first. Probably that's what? What have I done? It activated it. Okay, it activated it. Now I close these, and now you open it, and it should be there because the environment needs to be active. Probably for these to be picked up. Mm. Mm. No, it's not. Why? Oh God. Restart kernel. Come on, again, I didn't want to use. I yeah. Anyway, probably I might just not want to test. I gotta figure this out. Like it last time I got it to work, but now for some reason current. Okay, but the current one is select the kernel. So the current one. Yeah, but why does this one show up here? It's not fair because that's definitely not gonna work because it's not the one that is here selected, and I can't just change that for some reason. Mm. Select a kernel. Mm. So Python. That's not what I wanted. So Control Shift P. Come on. Stupid stuff, man. Stupid stuff. Select interpreter. Enter the path. I mean, it's this one here, right? So let me just enter the path. Let me just browse to it, right? So I'll go to the workspace and the prototype, and I'll say, look, that's it, right? Scripts, Python, that's it, right? That's the one that I have, but it does not allow me to select it here as a kernel for some reason. It's pretty annoying, to be honest. It is not started. So it picks it up correctly, but then it's just connects to. Yeah, that obviously doesn't work. Fuck it. Anyway, we'll probably have to do without testing today, or we'll just test with an actual notebook started from these environment. Yeah, we'll do that. So we were thinking about the implementation of rules and stuff like this, right? So we're thinking about how are we going to implement like a flexible enough system of rules where we can do things like this. And we're saying, okay, cool. So we're going to have gates so we're going to have rules. The rules is really always just going to be something like this, right? So you've got an input and then you've got an output. So the input of the rule, or it should be rather match, not input. So it should have match, and then match can be, this can be a node, this can be, it's not a node. I mean, this should be more than just a node. It should be like, it should be like a, hi, by the way, I see some people are joining. Cool. I don't know. I'm not super used to the OBS stuff, so I don't really see much when someone's joining. But hi. So okay, so where I was going. So it's the thing is I'm having a bit of a hard time trying to figure out how I can, what's the most flexible way to implement the match, right? So are we gonna go node by node, right? Like, so we're gonna match nodes because we need to map it to qubits, right? Because we're gonna have a system that has multiple qubits. And we always say we have a gate, and then this gate is a 1 qubit gate, for example, and you always map it to a qubit somehow. So that mapping kind of, I don't know where this happens, right? Because we're gonna have a rewrite function that takes a set of rules and just applies the rules, but then we'll have to pass a mapping, I guess. And that's what's a bit from an interface perspective, from like the programmer's perspective, that's going to be a bit complicated, I think, to handle. or I don't know, it's sort of in a user-friendly way, right? Because I can like this means I need to expose something like yeah, unless I need to expose at least what qubits, how many qubits these rules are referring to for this to make sense. Unless I'm kind of forcing the user to know about the internals of the rules. But I guess so. Why not, right? So a rule is going to have a rule is going to have uh, a certain amount of qubits that it operates on, right? Um, I'm feeling a bit not comfortable with the fact that then we have the controlled operations, which kind of I want to have them flexible enough so that you don't have to specify, you know, um, how many, like you don't have to re-implement the rules for like an arbitrary number of controls. But to be honest, it doesn't really matter. It shouldn't really matter. Like I want to apply a rule. So I have a match. I have a match that's the pattern that I want to match in the hypergraph. And so forget these for now. And that's the um is it replace? I guess that's the right language, right? It's not output, but it's replace. So that's what I want to replace the pattern for, right? So let's say match a node with a zero, or match like, match a specific hyperedge. The easiest is just kind of will be to match nodes. That's for single qubit gates. How would we specify two qubit gates? And you would have to, it's always nodes. To be honest, it's always nodes. I think the match is always nodes. It's just that you're going to have to evaluate these per hyperedge if there are multiple hyperedges. The same that we do it currently, where we just run the gate multiplication per hyperedge, and then we take a look at the system level. So if there's something that is not in hyperedge, so this is always going to be nodes. Um, Nodes, yeah, qubits, right? I mean nodes, qubits. So it's like, you want to match things like, 0, 0, right? You want to match things like 0, 1, or you're going to say, I want to match things like, you know, actually, what are the types of things that you want to match? Like, for example, does it make sense to say I want to be able to match, whatever one? That's the same like just specifying that you want to match these, right? But you want to be able to say I want to match. Yeah, I think I'm not gonna allow the sort of the any kind of thing, because it adds too much complexity into how this is implemented. Like, I think the match has to always be implemented like strictly, like you got to specify what you want to match. Like, do you want to match these? 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 It's always in the Z basis, right? This for sure. So it's always a Z basis match. And yeah, and you do have to have a we do have to have a matching, but it can be implicit, right? So it can be implicit in the sense that the match can be um, it's a least, right? It can be something like these, um, and then we'll just have to do the rewrite rules. So the input map is going to always be it's gonna have to be here, where I guess an input map would be something like um, literally, right? So I can actually say it can actually be something like these, right? So we're mapping, you know, hell, it could even just be like that, but that's probably a bit illegal. But we could do it like these, and then um, we deal with the fact that maybe the map is just not complete. And so then we spit out an error for a rule, so the rule cannot be executed. Um, so the rules are always defined like these. Um, Now, how do we define a but then it's kind of like we can define arbitrarily, like we can definitely. Oh, wait a second. No, yeah, of course. And how would we implement like a say? So what will be the match for like a CCX rule? So it would be basically, you would just actually do 1 1 1 0, so that this would be one match, and then you have another rule with this match. So you'd have two rules. So the CCX would be two rules with two different matching patterns, right? So you would match these, and then these would basically be turned into like these, and these would be, maybe that's a shorter way to define. Maybe that's a shorter way to define the rules, and to be honest. No, because okay, yeah, or maybe the thing is, these two here will have to actually be um, an array of complex numbers, because it's a single qubit state that you're matching, right? And it's going to be complicated. It's going to be tricky to think about, like, do we need to match up to a global phase or not, right? That's going to be another question that we'll have to ask ourselves, I guess, when we work on these. So and how do we represent the replace? Yeah, well, yeah, just like these. It's just we'll need the fraction. So state. Yeah, that doesn't work because that's really just for the one qubit case. If we specify these, then we have to. I'm curious if it will. Like, I'm curious. Like, let's work through an example, right? Because I'm curious if it's correct to do it like this. Let's say the control X, right, would be basically you would have two rules. So one rule that does like turn the 1 0 into a 1 1. Oh God. And another rule would be the 1 1 turns into the 1 0. So this will be the two rules, right? And so now let's work out how these. So if our hypergraph is in the plus plus state, right? Before we apply these rules, we need to do a z-axis expansion. So these will basically create four hyperedges, which will just be the 0 0, the 0 1, the 1 0, and the 1 1. And so and then we apply the rules. And so when we apply the rules, these rules will just basically catch these 1 1. Oh no, sorry, it was the 1. So what we're doing is the 1 minus is the example that I want to have, and I want to have it for the I want to have it for because of the phase keepback. That's what I wanted to check. whether this would catch the effect well. Because this is essentially 0 plus 1 and then 0 minus 1, so this is 0, 0, and then 0 minus 1, 1, 0, 1 minus 1. Is that correct? Is that correct? Correct. If I open Quirk, it will be quicker to test that. So we'll just open these and check. So if we have the plus and the minus, right? We have this is another. Okay, yeah, because that in this case the leftmost is the bottom qubit. We should stick to this convention, so it's going to be easier to test stuff. So this is basically like that exactly. So if we now, and that's probably going to be the way we're going to execute things. Is that now it's the question, right? Like, you know, in reality, this will be here. In reality, this will be here. But I'm not so sure if that's the. Yeah, that's probably the right thing to do. But like, I'm not so sure if this is gonna. If this is really gonna show. It's gonna illustrate what the phase kickback, but probably yes. I mean, it's gonna be like these. So it's like, I don't really care because the sign is outside, and so then then basically this is replaced by, according to this rule, by 1, 0, and now am I doing this correct? Am I not mixing up stuff right now? So, and now, and if now we would want to, that is, oh no, sorry, in the 1, 0, it's 1, 1. Yeah, there you go. That's what I was missing. So it will actually catch two of these elements and change things like these. And if now we will want to do the factoring, then we will actually end up with the minus plus state. Yeah, because these two will merge. Yeah, so that should pretty much work. I mean, it's correct to the. I think it's still correct to define the control X like these. It will even work in these cases, which is exactly, which is really what I want to happen, right? Yeah. Okay, so we'll have rules that so we'll have match and replace rules like these. It's, to be honest, it's just really going to be but it has to be like that. I have to give it a fraction because I'm going to need that to implement things like the Hadamard, right? The rule for the Hadamard would be, for like the 1 qubit Hadamard, right? It would be like these. And so we would say first match. Oh god, what am I doing? The first rule would be match, match 0, replace, and that actually has to be at least a state, which is then, what I want to replace this with, which is, a 0, and then what's the fraction, right? And that will be, 0.7 plus 0.7i, right? And so that is the way. And so this is basically the Hadamard gate. So this is the Hadamard gate. As these not an array, it's just the object, it's just a rule. So that's the rule. The rule, it's got to match, and it's got to replace, and the replace is basically a list of things that we want to replace this for, a list of edges. Now, is that a list of edges? How am I going to know? Is it that if it's just one? Because if I design it like these, I'm implicitly telling the system that these are edges because I'm giving it a fraction. I guess so. I guess if there's fractions, because if I want to just the x gate, right? Yeah, I just give it a fraction of 1. That's fine. It can all be hyper edges. Actually, it's better this way. It's always going to be hyper edges. But no, it's not, because let's say if I have already hyper edges and I want to just transform a nodes, I don't want to create hyper edges. I just want to replace nodes. And so but that's also not correct. It's not branches. That's not the Hadamard gate. That's definitely not the Hadamard gate. The Hadamard gate is not, that's not what it's saying. Not at all. It's replaced with a plus state, right? And replaced with the yeah, it's replaced with the yeah. I'm stupid. I'm stupid. It's 2 rules. The Hadamard gate is 2 rules. One for the 0, one for the 1. So minus a 1 and turn it into a minus, right? That is the Hadamard. There you go. So I'm not like the replace doesn't have a fraction, or it's got a fraction of. Maybe that's the rule. If I give it a fraction, or just give it a just call it like hyperedge or something. If I give it a fraction, then it is going to create a hyperedge, right? So and that fraction is going to actually be a complex number. It's going to be a complex number, and then this is going to create an edge, basically. I think so. I think that could work. I think, to be honest, that could work. So When would I have to do that though? What operation would do that? I just kind of realized that for control X, what did I say? So for control X, you would match only 1, 0, and basically replace that. I think we don't need to specify hyper edges. Yeah, we don't. It's way simpler than that, because if the precondition is that we are going to do an expansion um, of the system on the Z basis first, which is totally inefficient, but like it's not the purpose. We're not trying to build an efficient simulator. We're trying to build a simulator that is verbose enough so that it's easy to understand what the algorithm is doing. So if the precondition is we have an expansion, then we already have all the hyperedges that we need. We don't have to create more. So that's actually way simpler. It's just a replace. The thing is, do I want to replace? Do I want to replace something for multiple? Because I'm just gonna say that's just replaced by these, right? And that's, yeah, pretty simple actually. Then I have two rules. So then I just have um, a rule that does these and replaces these for that. Um, and so if I want to implement a, you know, CCC control like a Toffoli gate, then it's still two rules. The rule size of the match part increases, right? If I want to keep it generic, but because I'm expanding everything before, then I really don't care, you know. Um, we won't go beyond probably 5 qubits or something like this. So, but because then the system is just going to explode, right? We're going to have suddenly like 32 different hyperedges. But then we can think about smarter ways to expand the system, maybe. Because if we know that the match of a rule is rather simple, so there's just one match, it's always just one match. And then we can think of, if we didn't want to go the efficiency route, we can just, if we have a system that is in the plus state, we can think about a way of carving sort of these branches out somehow. But that's for another day. That's definitely not for now. Um, then why don't we just go for these? Um, so it seems like it's just that simple. An operation is a set of rules, a set of match and replace rules. Like I'm going to assume, it's the designers or the programmer's responsibility to make sure that those operations are actually unitary and all that kind of stuff. So I'm not really going to care about these. So you'll be able to essentially do non-quantum stuff here probably, uh, but that's not an issue, I guess. I'll ship that with a predefined set of rules, so you don't have to reinvent the wheel, but then you can just run your own. So I think that should definitely work. Now, how would I implement that? Right? So, because this is the metric stuff. So the only thing that I need to do is I need to actually implement something that, takes in a bunch of rules and checks for a match and then replaces that. Now, checking for a match will happen across the hyperedges, with a map that we have here. So this is what we have to build, the rewrite thing. So we kind of have to do that's a big thing. That's a big beast. We can keep it here and just say, call rewrite, and then we have an input map, right? Which can be, of any size, whatever, right? So we've got the rules, and we've got the input map. Cool. So what we'll probably do is, we just go rule by rule, right? So we say for rule in rules, we just now we have the rules, and now the first thing we have to do is find matches, right? And then there can be more than one match. So what I probably want to do first is check the hyperedges. Right, so I will just say for E in like self edges, and now it's like it's a match, right? So I would just basically say if self is match, and then we have the match, right, which is basically the rule match and the hyperedge. Then self replace edge, right? Or replace match. And you're giving this match basically an edge, and you're replacing it with a replace, right? That's all what you do. Yeah. Now I'm starting to think, but I'm a bit afraid of touching this because I wouldn't like to touch this whole concept of like the hyperedge, like nodes that are not in the hyperedge just have the hyperedge thing none. So it's kind of like because I find matches in edges, right? Find matches in system will be sort of the next thing to do, which is basically didn't I have something like now I can probably just use these get nodes, get node IDs, get qubit node ID in edge, qubit node ID in edge. Definitely not rewrite, so rewrite. I'm missing the input map here though. I think that actually it's probably given to the ease match and it's probably given to the replace match as well. Um, and so I want to have, yeah, what I actually have to do is kind of repeat that, but instead of E, just give it none because this is these are the not like the nodes that are not in an edge. And I think that's it. So that's what the rewrite is doing. Now I need to implement the match and the replace match, but it goes through the rules, and then it first goes through all the edges, and it's say is this edge a match? Um, if so, then replace, and it's like and then it's like is this rule a match for the qubits for the nodes in the yeah and so that they are not in hyperedge. So now I need to implement ease match and replace match. So ease match, and actually that actually has a self in here. So ease match, and ease match has got the match basically. It's got the am I writing match correctly? I hope so. It's got the edge, and it's got the map. Yeah, baby. And the replace match. So the replace match is got the replace match has got the edge, the replace, and the map. Cool. So the ease match should be easy to implement, right? Because what I have to do is I do so ease match false. We'll assume it's false, and then we basically return ease match, right? And so what we do is we kind of say, good, so we have an edge, and we want to know nodes self get node get so for match qubit node in edge. What I want to know is probably for the element in the match, right? So for I or for so how do I get the M in a match, right? So I get now I have the match, I have the I, and now I know first what qubit I need to. So the qubit is basically map I, which check for error. So that's definitely to do, and then because if it's not there, then we should throw an exception. And if it's there, what we should do now is basically get the qubit node and check for the state. I have the qubit. So now I need to basically get the node, which is basically self get qubit node in edge, right? And so this is basically get the qubit node in the edge, and that works also for edges which are when they are none. And it's qubit and edge UID. Okay, so right. So it's qubit and edge, right? Um, is edge or is edge the edge ID, edge UID? So, and now I say, you know, if we assume it's true. So if, to be honest, it's not like return true. So if we go through these, so if self, I think it's equal, right? State equal. So if the states are equal between the node state and basically M, right? M is actually a state. It's a state as a match state. So they're, if not equal, return false, basically, right? Because what I'm saying is, you know, for example, like you know, like a match would be, like a 110, right? Edge, you know, will just be like an edge which has like UID or whatever, and then the map will be something like Q0, Q1, Q2. And so sort of like qubit IDs. And so basically what this is doing is it's telling me get the state of qubit 0 in this edge and then check if it's a 1. And if it's not a 1, it's obviously false. If we go through all these and it's a match, then it's true. So that should be correct. Of course, there can be an error here if the map is not matching or it's not complete. Cool. Now the replacement is a bit more. I'm surprised quite how easy that is actually. You know, in terms of the actual implementation. I guess what's a bit more complicated is the it's going to be to make sure that we have the expansion, which I think I implemented it. Expand. Didn't I expand qubits? Look at this. So what is this doing? Oh, it's cheating. It's applying an identity. Okay. Maybe I'll implement a better version of these next time. But so what the replace should do is, to be honest, it should just replace. That's actually extremely easy, isn't it? like it should actually, it's the same thing, right? But I'm not comparing anything. What I'm just saying is I'm saying get the qubit node ID in edge. That's not what I want. Oh yeah, self nodes. So that is and actually, because this method returns the ID, because what I want to do is I want to make sure that I really, that's good. It's good design. I think it's good design from my side, because now I can actually just say, look, get these stuff and change the state, and the state is just M. Like that's just, it's not, this is replaced. So, you know, let's say you're replacing each of these. That's it. Like, how do I test that? I'd like to test that. Give me a second. So, but that the shit is not working. Like I don't know how to get, like I have the right environment here. I have the right environment activated, but when I open a fucking notebook, like it's picking the wrong thing. It seems to pick the right one here, but it says not started. And then it switches back to, oh wait, maybe now it's gonna work. No, it's just connecting, it connects to the other shit, man. Maybe, do we just need to start that? Jupyter version, Jupyter blah 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 blah. Jupyter notebook. Maybe I need to start the kernel. And then it's gonna pick it up. Like that's gonna open, like that should open my browser. What? Jupyter. Why? Jupyter notebook. Why it's not? I did install Jupyter, didn't I? How do I install Jupyter? God. No, Jupyter Lab. Pip install notebook. I thought I did install that. But it seems like I didn't. Oh, maybe that's why it's failing. But then why did it work last time? No idea. It's actually... Does it really say terminado in Spanish? Dude. Cool, let's see if that works. And if this would work, how would I test that? So what I would do is I would open the notebook and I would just say, let's do something simple, right? Let's start with an X. And so that just does this, and it turns a 1 into a 0, and it turns a 0 into a 1, right? So that's the simplest rule ever. That's X. That's the rules for X, the rules for life. Dude, I didn't have Jupyter installed in this environment. That's why it probably didn't work. Does this really take so long? Come on. So I would just say, you know, I would kind of like, I would start a system saying system equals hypergraph, just, you know, just one node, and then say system rewrite. And how did that look like? So I close this notebook, and then this would be like rules in the input map. And so the rules would just be this, right? So the rules would just be X, and the map would just be what? Q0. It's still writing. Come on. Yeah, to be honest, I'm running out of time. So I think I might just have to, oh, come on, come on, come on, you're done. Yeah. Perfect. No, why? Why? I don't want to do this twice. What is going on here? What's going on? So this now works, doesn't it? This should fire up my browser. Why is it not doing anything? Okay, but it's not complaining, so that's good. So, but this is what I should test. What the? Okay, so it actually does work. Perfect. If I now open this notebook, this should just work. And so if I literally copy that, but it's not a 1. So what I should be doing here is that's what it should be. That's what it should be doing. So this is the state 1, and oh, what did I do? And this is the state 0. So that's what it should be matching for. It's just an array of 2 complex elements. And so if I just look at this is work. It seems like it's working. It's not fucking working. Why it's not working? Okay, whatever. I'll just play with it in. So if I just click here, that should actually open it. Notebooks, testing. Fuck VS Code, come on. Running out of time, baby. So we'll not import gates. We'll just import these stuff here. Oh, but that's gonna break, I think. If I don't import the breaks, the gates. No, I don't have to import the gates. That should just work, it's fine. Yeah, that's worked. Okay, cool. And now I just do these. And what is that? I don't know. So this is X, and then what I just do is system draw. And hopefully this won't break, and it will just show me a, yeah, well, import NumPy. What about that? What about that, baby? 3 were given, so what did I do wrong here? VS Code. Is match self and self. There I go. And so I just now have to restart the kernel. And do this whole thing again. Let's see what happens. UID. So why isn't this working well? So this is the edge replace match. I'm replacing. Oh, it's none. Yeah, okay, cool. So is none, and then it's like if yeah. So this is basically, yeah, that's a bit stupid. So because edge can be, so UID is none, and then it's like if edge is not none, UID is like these. So that's what I should do, because it can be none, which means that it's not in, it's in no hyper edge. And the same goes here. So that actually, it's, you know, but this can happen outside of the loop. This can happen outside of the loop, doesn't have to happen every time. Right. The same here. Doesn't have to happen every time. Is that correct? Yeah, I don't use that anymore anywhere else. Is not none. It's not none. I will just restart and clear output, and we'll try once more. Hopefully that works. There you go. Yeah, that worked. At least it printed stuff, but I don't think it replaced the thing. So, didn't break. That's good. Didn't break. But to be honest, it didn't actually do what I wanted it to do. So it didn't match. It should have matched these and replaced it with these, but it didn't. So rewrite. If it's a match, replace the match. Then I give it the rule. E. And that works. That should be the one that's being executed. And so self node, self again, each getting the qubit in the UID, which is none, and changing the state by M. So iterating with the replacement. It seems like that it's not then a match if it's not being replaced. So this means that is match. So this is none, and I'm going through these and just saying that if node dot state and M are not equal, return false. So hmm, I guess that's what's happening, right? I'll probably debug this later because I just literally ran out of time. So this is probably it's not a match. It doesn't find this to be a match, and so. But okay, it doesn't break, so we're almost there. That would be surprisingly easy, to be honest. This means I only have to have a clean way to expand the system. It's not printing, but maybe because it's just. Yeah, I really do have to go, sorry. So this, I'm not so sure if it's actually picking up the change actually. But that'll mean that the replace is not working. So it's not printing. Then it's a replace and not working. So for each replace, you get what am I doing? So I'm doing, I have the map. So I'm getting the qubit in the map. I'm getting the qubit in this edge and replacing the qubit by the qubit state by M. Print M. Just one last test, okay? One last test. Kernel, restart, restart. Let's see. Look at these. It does a double replacement. It actually works, and then it just the other rule replaces it back. What I should do, what I should do is that it, yeah, I get it. So if replace match, so uh, a rule is matched, and once a replacement is done, so the rewrite it says is replace the match. It's not that easy because I do want to have multiple replacements. Got to think a little bit more about this, but time's gone. So thanks a lot for everyone who's watching. Um, Stay tuned for more. Gotta go now, but it works. I'm happy. Bye bye.